Hello, this is Mrs. Marquette. Today we're going to start a brand new chapter. It's chapter 9. And chapter 9 is all about rational expressions and rational equations. Now, when you hear the word rational, I want you to really think about the root word of rational, which is ratio. Now, ratio is another word for fractions. Okay, so everything we do in this chapter is going to have something to do with an expression or an equation that has a fraction in it. Sometimes these fractions are going to be really simple. Sometimes these fractions are going to be a little bit more complicated. So as we start off chapter 9, we are going to graph some rational functions. So a rational function is a function in the form f of x. So this is like the name of the function. And this function is actually made up of two other parts. It has a numerator part, p of x, and I'll put numerator. And we've got a denominator part, q of x. Now that's a lot of stuff going on in that little fraction. It might be a little intimidating with the f of x, p of x, q of x. But I would really just think about the fact that we have a numerator on the top, we have a denominator on the bottom, which makes this a big fraction. So let's look at a couple examples. I have a 2x squared plus 5x minus 3 all over 7x. If I just think of what is the p of x part, what is the numerator, that is this top expression, 2x squared plus 5x minus 3. Notice there's nothing more complicated inside of that numerator. That's a quadratic that we've really seen before. And the denominator is just 7x. 7x is even a more simple piece. So when we deal with rational functions, sometimes it's easier to just think about the numerator, just think about the denominator, and then work with each piece. B, if you look at p of x, that is the numerator. The numerator is just 6. The denominator is 7 minus x. Here our numerator is a little more complicated, but not too much. It's 2x to the 8th minus 9x cubed, and you might already see, oh, I could probably factor out a GCF with that, and that's exactly what we're going to be doing in this chapter. And then the denominator is 4x squared plus 7x minus 3, which is a quadratic. Okay, so that would graph a parabola. So today we're going to just graph a very simple type of rational equation, and those are equations that really just have a numerator that is just a number. So everything we graph today is just going to be one number in the numerator, and then we'll have some sort of variable in the denominator. And when we have this kind of a function, we get a graph called a hyperbola. Okay? A hyperbola, you'll notice it has one, we call it a branch, and then a second branch in the opposite quadrant. So here, if you remember your quadrants from Algebra 1, we have quadrant 1, 2, 3, and 4. Okay, so each of those quadrants we can see that one branch is in quadrant 1, one branch is in quadrant 3. And if we think even more so about what we did in chapter 8, notice that neither of these branches touch that line x equals 0 or the line y equals 0. Okay, if you think about what we called those with exponential functions, those are asymptotes. So the x-axis, or y equals 0, is a horizontal asymptote, so that's this one right here. And that y-axis, my vertical axis, is a vertical asymptote. So again, remember that an asymptote means that my graph approaches it. Notice it gets really close to the asymptotes. But it never actually touches either of those two asymptotes. They're kind of like force fields, which keeps my graph, in this case, all in the first quadrant and the third quadrant. And the domain and range, it looks like other than those x and y's are, and if you look at the domain and range, every other x and y value is covered except for x equals 0 and y equals 0. So domain is all reals except x equals 0. So I can't hit x equals 0. And the range is all reals except y equals 0. Okay, So we can really just say like all real numbers except x equals 0 and y equals 0. So if I want to look at a couple different examples of this, I might hop over to Desmos here. And this is the graph that we just saw, y equals 1 over x. Notice that I have up in that right-hand corner, the first quadrant, we have my branch, and in my third quadrant, I also have my branch. But if I change this instead to be a negative number, notice what happens. My branches flip-flop. I've got a branch in the second quadrant and the fourth quadrant. And even if I change these numbers, if I make this a negative 3, I still have branches in the second and fourth quadrant. But if this is a positive 3, I am in the first and third quadrant. If we think of why that happens, we can remember, you can think about the fact that our quadrants, quadrant 1 and quadrant 3, both the x and y values all have the same sign. And if we have a fraction, a positive number divided by positive is a positive, a negative divided by negative is a negative. So it kind of makes sense that our positive a value would make things that had positive values. And then if we have branches in 2 and 4, we have a negative and positive, a negative and positive. Now if you divide those numbers, you'll always get a negative value. So you can kind of think about what that means for your x's and y's when you're doing your graphing. So the other thing to be aware of is all rational functions have the form y equals a over x minus h plus k. All right, we notice that we've got this x minus h. This h value is going to affect how our graph moves horizontally, and our k value is going to affect how our graph moves vertically, which makes sense for us because h usually affects our graph horizontally, k usually affects our graph vertically. But think about what that means. We now have a horizontal asymptote, which will be affected as I go up and down, and a vertical asymptote, which will be affected as my graph moves left and right. So we can really think about controlling our graph just with those two asymptotes. The other thing to be aware of is this negative means that I'm always going to move my horizontal value in the opposite direction of what I think. And my k value is positive, so that's always going to be in the same direction. So I've got y equals 3 over x minus 1 plus 2. If I look at just this part right here, notice that I have x minus 1 in the denominator. What we can think about is what will make that denominator 0, because division by 0 is bad. So we know that division by 0 is a problem, so I can say, well, what would happen if x minus 1 equals 0? Okay? Or we'll really just say that x minus 1 can't be 0, right? That's a bad thing. So if I add 1 to both sides, I get that x cannot be 1. Right? So this is actually something that's really important, because then I can say, okay, that means that this line x equals 1 is an asymptote. I can't touch that line. The other thing that we can see is this value 2. Okay, originally our y asymptote, our horizontal asymptote, starts at y equals 0, but that shift is going to say that my asymptote goes up 2. So our y asymptote is going to be y equals 2. So I can graph that one as well. And then we've already seen that when we have a positive a value, positive number in our numerator, we're going to have branches in quadrants 1 and 3. So I graph my 2 branches just like so. Okay, it doesn't have to be a beautiful sketch, but that is the general shape of our graph. Now, looking at those asymptotes, we can see what x can't be and what y can't be. So x can't be 1. All right, we already said that. And then our range is going to be all real numbers except y cannot be 2. So that is really our domain and our range. Okay, so it's everything except y is 1 and everything except y is 2. All right, checking out number 5, again, I'm going to look at the denominator and I'm going to look at the number tacked on at the end. So first things first, I've got x plus 3. Remember that your denominator can't be 0. So the thing that would make that denominator 0 is actually negative 3. So we already know that our domain is x can't be negative 3. which also means that my horizontal or my vertical asymptote is right here at x equals 3. The other one to look at is our y asymptote. Okay, it starts at 0, but a negative 1 is going to move the whole graph down 1. So I'll say that y equal to negative 1 is my horizontal asymptote. So I'll put that right at y equals negative 1. And now I want to graph my branches. Look at your equation. Negative 2 in the numerator means that I graph my branches in 2 and 4, the quadrants that have opposite signs, right? So it's just flipped it because of the negative. So we've done our domain. Our range is going to be all real numbers except y equals negative 1. So I can say y can't be negative 1. And again, that's just like all real numbers except for the two asymptotes. So once you've drawn your asymptotes, you can get your domain and your range. Okay, y equals negative 1 over x minus 4 plus 3. I would maybe pause the video and try this one yourself, but I'll keep going with it. Look at that denominator, x minus 4. That can't be 0. So if x minus 4 can't be 0, then x can't be 4. So I'm going to go ahead and draw a vertical asymptote at x equals 4, right? Which means that I already know the domain is x is not equal to 4. It can be any other number, just not 4. The other one to look at is this value of 3. My original y equals asymptote is y equals 0, and that plus 3 is going to move everything up 3. So my y equals 3 will be my horizontal asymptote. Y equals 3 goes right here. And because our value of a is negative, we're going to put our branches in quadrants 2 and 4. And that is our hyperbola. The last one, y is 4 over x. This one, I mean, it looks more simple, but sometimes that throws us off. We know that the denominator can't be 0, which means x can't be 0, right? It's not trying to trick you. Just draw your line at x equals 0. We also don't have a number tacked on at the end, which means that if our asymptote starts at 0, it's not going to move up or down. So y equals 0 is the horizontal asymptote. So I'll graph that one as well. Okay, so right now we've got the domain is x can't be 0, and our range is y can't be 0. Okay, then where do we draw the branches? We have a positive number in our numerator. So I can draw my branches in quadrants 1 and 4, or 1 and 3 rather. And that's our hyperbola. So those are the 3 things to look at when you're graphing your hyperbola. First of all, what can't the denominator be? What can't x be? Then look at your horizontal asymptote. And then finally, where do you sketch your branches? The things that you're really going to be tested on and looking into are your horizontal asymptote and your domain. So what can't x be? What can't y be? So really think about those 2 pieces of your graph. I will talk to you guys later.